talking about multiplication and division word problem structures. Let's take a couple of notes before we begin. Multiplication and division have an inverse relationship. What that means is that if we had 5 times 3 equal 15, 15 divided by 3 would equal 5. Because of the related facts, the inverse relationship is the opposite. You multiply and you get a bigger answer. When you divide, you get a smaller answer. So when you multiply, the answer is called a product. And when you divide, the answer is called a quotient. So the product, when you multiply, product will always get bigger. And when you divide, your quotient will always get smaller. Word problem structures are set up in this way, where you will always have a total line. In this example, you'll see we have 5 boxes. Those would be the number of groups that we have. Inside the boxes, let's say, because if I'm multiplying, I know that I have equal groups, so let's say I have the number 6 in each group. So that number is the number in each group. This, of course, is your total line, which would be your product if you're multiplying, or it would be the quotient if you're dividing. But your total is where you would put your whole. So let's say that this was our word problem, and just by looking at this, even if I didn't have a word problem in front of me, if this was a structure that was designed for the word problem, I could tell right away that I had 5 groups of, how many in each group? 6. So my total would be what, class? That's right. My total would be 30. So 30 would go up there in my total line. So that the way that it's set up is you'll always have a total line on the top. And that could be where you put your product, or it could be where your quotient starts and you work backwards to divide to find your answer. So total on the top, you have your number of groups, and then inside the box you have your number in each group. Now here are a few examples of groups that you can have in a multiplication problem and the number in each group that would go with the group. So let's say, for example, if your group is boxes, then the number in each group could be the pens in those boxes. Let's say you have plates as your groups. Well, on top of your plates, you could have cookies. Cookies would be the number in each group. Let's say you have vases. Well, the number in each vase would be your flowers. So the way I want you to think about groups and the number in each group, the group is going to be the big thing. So the plate, the ice chest, the table, the classroom, a bus. The number in each will be the little thing, the smaller thing that can fit inside or go on top of your group. Like pens and cookies. Students would be the number in each bus. You could have water bottles inside of the recycle bin. So groups are your big thing, and the number in each group would represent the smaller thing that would fit inside your group. Okay, students, let's use this strip diagram as our word problem structure for a multiplication problem. Looking at it right away, which one represents the groups? Is it the number inside, or is it the box itself? Excellent. It's the boxes. So I have 1, 2, 3. Those represent my groups. And the number inside, the 5, of course, is the number in each group. So let's say, for example, that the groups, let's label it, our groups would be plates. So there's 1 plate, 2nd plate, and a 3rd plate. So we have 3 plates. And let's say the number in each group would be cookies. So you have 5 cookies on this plate, 5 cookies on this plate, and 5 cookies on this plate. And you're looking for the total amount of cookies. Well, what would you do to solve that? Absolutely, you would multiply. You would multiply how many groups you had. You had 3 groups of, remember that multiplication sign means groups of, 3 groups of how many were in each? Well, double check. How many were in each group? 5. You had 3 groups of 5, which means 3 times 5 would give you a product of what, class? Excellent, 15. Because 5, 10, 15. 3 times 5 gives you a product of 15. So 15 would go here at the top. And just as a reminder, remember the groups represent the big thing, and of course the plate, a plate is much bigger than a cookie. So the plate represents your groups, and the cookies are the number in each group, because the number in each group will be the small thing, and the group would be the bigger thing. Okay, let's try a few word problem examples together. Okay, so here's our word problem. Remember, you read it 2 times. First time, read it all the way through. Second time when you read it, you create that mind movie. It says, Cecilia wants to buy 12 pumpkins that cost $6 each. How much money will she spend? Okay, so in my mind movie, I saw right away that Cecilia was buying pumpkins. How many pumpkins did she want to buy? That's right, 12 pumpkins. And how much did each pumpkin cost? $6. Good. So I have my information. It's right there in my word problem, so now I need to set it up. So I'm looking for how much money will she spend on all those pumpkins. So I'm going to set it up with the total line on the top. I'm going to draw my rectangle underneath that are going to represent my groups. Now I need to go back to my problem. Which one would be my groups? The pumpkins or how much they cost? Absolutely right. It would be my pumpkins, because my pumpkins are the bigger thing. The $6 is how much each of them cost. So since my groups are the pumpkins and there's 12 of them, I need to cut this long rectangle into 12 sections. Okay, so there are my 12 pumpkins that represent my groups. And inside each group, I'm going to put how much each cost. So 6 would go in each group because each pumpkin cost $6. So my number in each group was $6. And there was a total of 12 groups, which represented the pumpkins. I am looking for the total amount of money, so of course my unknown would be my total. Trying to figure out how much money it would cost to purchase all 12 pumpkins. Knowing that I had 12 groups of 6, my multiplication sentence would be 12 times 6 equals question mark. So since this is a total unknown problem, I know that I'm trying to find the product. So I'm going to do 12 times 6 to figure out my total. I could choose several ways to solve this, but the best and fastest way would be to actually multiply it straight out. It says I have 12 groups of 6. So if I have 12 groups of 6, that's the same as having 6, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and trying to find the sum. But we all know that this method takes way too long, the repeated addition. So we are just going to multiply it straight out. So looking at it, I know that I have 12 times 6. So I can skip count by 6's. 6, 12, 18. Let's write out our 6's. And then all I would have to do is count 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 groups of 6 gives you the product of 72. So Cecilia would have spent $72 on all 12 of those pumpkins. The situation equation for a multiplication or division problem will always be blank groups of blank equal blank. So here, easily we knew, after creating our word problem, that we had 12 groups of 6 equal 72. So our situation equation was 12 times 6 equals question mark, because and the solution equation for this problem is how we solved to find our answer. And the way that we solved was just multiplying 12 times 6 to equal the total, what we were looking for. Since 72 was our answer and we had a total unknown problem, both the situation equation and the solution equation were exactly the same. 12 times 6 equals question mark. Going back to our word problem and making sure that we answer in a complete sentence the question, how much money will she spend? Our complete sentence is Cecilia will spend $72 on 12 pumpkins. Okay, students, let's try another problem. This problem says